this video, I will talk about weights in artificial neural network, and we will discuss these weights with a theoretical example. So let me just go straight to the example. Suppose we have input layer. In input layer, we have two inputs. These inputs are x1 and x2. Suppose the hidden layer has three neurons. This is just a description. And at the end, we have one output neuron. Let me just draw a line which represents the weight. For example, this information has a weight W1. Then we have a weight W2. Then we have a weight. This line is not a weight. You may say these are just the lines. Okay, with weight shows that how much this feature X1 contains a weight. I mean, how important is this X1 is. So we have probably this is W3. And from X2, we have, for example, weight W4. Then we have weight W5. And we have a weight W6. Next, from this value, we will calculate that value. From this value to the final output, this is hidden layer. This one is the hidden layer. This is input. And this is on the right hand side is output. And here we have a weight W7. We have a weight W8. And then we have a weight W9. Let me just calculate the weights on this neuron, the results on this neuron. Here, for example, I have, maybe I write it separately. For this neuron, we have X1 W1, this term. Then we have X2 W4 plus X2 W4. Suppose it has an output E1. And according to the theory, we apply activation function on this E1, we get A1 value. Now we calculate the next value on this second neuron of hidden layer. That will be, you may see what is coming on this, what information is coming from this. So we have, for this, from X1 we have X1 W2 plus X2 W5, which is equal to E2, and you apply the activation function. That activation function can be sigmoid or Rayleigh function, rectilinear function. E2, you get A2. So it means that we get A1 after applying function on E1. Then we have f of E2, which is A2. Then we have f of E3, which is A3. And for this neuron, we get, for example, E3 X1 what we have from x1 we have weight W3, x1 W3 plus, then we have x2 W6 plus x2 W6, and the sum will be equal to some number E3, and you apply the activation function on E3. At the end you get A3. So we have A1, A2, A3. These are the values that we get after applying the activation function. Suppose now this becomes an input. Suppose we have next value over here. I can write it over here. First we take a linear combination. A1 W7 plus A2 W8, A1 W7, A2 W8, and A3 W9. So we have plus A3 W9, and when you sum all these values, you will get, suppose, E4. And at the end, you apply activation function on this E4, you get Y hat. That is our input value over here. If you don't understand that, which I say in every video, just follow that. In the next video, maybe I will give you a particular example where we have particular weights. W1 may be equal to 0.2, W2 will be equal to 3, something like that. So I will talk about that in the next video. So that's at the end what we get. We get this Y hat over here. Now you have to decide either to apply sigmoid function or rectilinear function or Rayleigh function. It becomes very important to decide the activation function. Sometimes, for example, Rayleigh function only give you the positive answer. And sometimes in the data set, negative values also become very important. In that case, you cannot apply Rayleigh function. And also, sometimes you have more than one output. Here you have only one neuron in output. One neuron in output. Sometimes it happens that you have 3 outputs. Let me just give you an example to understand that how it works. For example, in the drone example, to guide a drone by ANN, you need, for example, 3 inputs and 3 outputs. The 3 outputs will be speed, direction, and also altitude. And the 3 inputs may be position, speed, and altitude, so on, altitude and so on. So there can be multiple inputs. It can be, for example, flight plan. So you may have more than one input, or maybe 3 or 4, 5 inputs, and you have only 3 outputs as well. And hidden layer will come. It depends how many hidden layers are required. So this was all about the weights. In the next video, we practically look at the example, and we will see how to find the errors and how to train in artificial neural network for limited data. Thank you for watching.